Hi everyone, welcome to Brilliant Tech and Teams, creating a platform for streamlined software development. I'm Gonzalo Fernández, Head of Software at Telefonica Digital Innovation, and today I'm going to talk about how we can streamline the process of building software in a company based on our hands-on experience. So, as our engineering team became bigger, we started to face typical problems of growing, and even if we had a clear tech stack for all teams, different ways of delivering, using tools, and deploying appeared. And this created a fragmented situation, making the release process more complicated and causing problems in many areas. We faced several challenges like technical fragmentation from inconsistent tools and deployment methods across teams, resource inefficiency due to duplicate efforts, growing operational complexity in managing services and alerts, a poor developer experience that made onboarding and development slow, and a limited financial visibility that made it hard to optimize spending. So, our analysis revealed that the key to solving most challenges was adopting a holistic approach to the entire software development lifecycle, aiming to deliver faster, efficiently, and always with confidence, minimizing bugs and production issues. So, this also required transparent management of both platform and application infrastructure to reduce complexity for development teams. And to make this possible, we decided to build an internal developer platform following some strategic key points. Standardize critical processes in order to bring consistency where matters, automate repetitive and cross cutting tasks to save time and reduce human error, enable developers to focus on building great features, removing the burden of infrastructure and pipeline complexity, establish a strong environment control, ensuring controlled delivery, and empower teams with visibility into cloud costs. And what we did was to build an internal developer platform that fits our needs, and we defined these core components: an infrastructure as code orchestrator to automate both platform and application infrastructure, version generators for the infra to achieve environment parity, environment-specific configurations in our version control system repositories directly aligned with their matching infrastructure environments, automatic configuration injection. Here are orchestrator populates environments configurations in the repositories with essential details like, database credentials or DNS settings, for example. Okay, standardize standardize a branching strategy to enable us to create automated and reusable CI/CD pipelines across all teams. Of course, a self-service portal where developers can easily provision infrastructure, access to platform services, and so on, and cost visibility in the platform to help teams track usage, spot inefficiencies, and optimize resources. Right? Let's talk about our orchestrator. Our orchestrator has been built with Terraform and Terragrant tools and some other automation scripts in order to abstract infrastructure complexity. With Terraform, we define resources in a declarative way, with Terragrant, we orchestrate and manage modules and dependencies. However, developers simply request resources through a self-service portal without needing to understand the underlying tools. Okay? Um, I want to highlight a key challenge we faced because we need to deploy applications across multiple service units. And what is a service unit? A service unit is an independent deployment environment that often serves users in a specific country and sometimes operates even under a different brand. So this adds significant complexity because different service units may require different versions of the same application and potentially different infrastructure stacks to support their unique needs. So we have taken this requirement into account and we have defined three key points here. First, platform infrastructure is bundled and versioned. So each infrastructure stack is versioned and is starting GitHub as a platform release. For example, version 1.2 or version 1.3 of our platform, bundling all necessary Terraform modules and configurations. And this approach ensures traceability, safer deployments, and greater predictability. Second, flexibility for service unit requirements. Our system allows each service unit to adopt the platform version that best fits its needs. So, when a new component is required, we simply update the corresponding platform version, avoiding the need to rebuild the entire stack. Third, automated deployments via a generator system. We leverage a generator system that reads platform version metadata to automatically provision infrastructure, and this ensures consistent rollouts, reduces manual effort, and minimizes the risk of errors. So this architecture, in short, it enables us to handle customized deployment across different service units. It makes infrastructure changes safely with full traceability, and it scales infrastructure management without duplicating work or introducing configuration drift. Well, one of the first important steps in our journey to introduce an IDP in our company has been to standardize the way that teams work. We agreed on a common strategy across all teams, and this alignment has been crucial to implement our paved road, allowing us to automate processes, improve collaboration, and warranty consistency across applications. Because by having all teams following the same practices, we were able to build reliable tools and workflows that work for everyone. And after aligning on a branching strategy, we developed reusable CI/CD pipelines to promote consistency, to enhance security, and minimize manual setup. Using GitHub Actions and a custom CI/CD internal tool, we decoupled workflows from specific build and publishing technologies, empowering teams to choose the tools that best fit their needs. Configuration details, including secrets and environment variables, are injected by our orchestrator, enabling seamless deployment into the IDP managed environments. And this setup maximizes reusability, and it still allows teams to customize workflows by adding additional steps when needed. We implemented ephemeral deployments to enable isolated short-lived testing environments to ensure that code doesn't break the main branch. These are automatically created for acceptance testing in our dev environments and destroyed afterward. Okay, and anyway, these deployments can be extended if additional validation is needed, for example, to do some troubleshooting. Well, when building an application, it is essential to use multiple environments throughout the software development lifecycle, each serving a specific purpose to enable teams to develop, validate, and deliver reliable software incrementally. Ensuring consistency and proper use of each environment is critical for maintaining quality, catching issues early, and providing a smooth path to production. Uh, Environment parity here is made possible by Orchestrator and our CI/CD pipeline, as you can see in this figure. They enforce uniform architecture, workflows, and tooling across all environments, eliminating surprises and helping ensure reliable code transitions through the pipeline. Another important topic is cost transparency. From the beginning, we decided to integrate cost transparency into our IDP instead of leaving cost management only to finance or infrastructure teams. It promotes shared responsibility because when developers can see and understand the cost of the resources they use, they start to feel ownership not just over the code, but also over the infrastructure. This is very important. It also allows teams to make the informed decisions on time because teams can quickly detect unexpected resource consumption or cost growth, and take action before the issue escalates. It also enhances collaboration with product and business stakeholders. By providing real cost data, it is easier to explain why certain technical decisions are necessary, or why prioritize optimizations, or even renegotiate budgets or timelines. In this figure, you can see that we have created a dashboard that offers full visibility into infrastructure costs at the application level, broken down by environment like dev, staging, production, and also by resource type. Well, okay. Additionally, we allow teams to set a monthly and an annual forecast for their expected costs. So during the month, the dashboard shows the real-time evolution, and this helps teams to quickly identify if they are staying within budget or if they are at risk of exceeding it. So it gives them time to take an action before the end of the period. Okay, to wrap up, I would like to say that introducing an internal developer platform is not something that happens overnight. It is a journey that companies adopt step by step, and it is important to understand that you don't need a complete self service experience from day one. At the start of building our IDP, we focused on delivering functionality fast to support the needs of the development teams, and initially, not everything was automated through the self-service portal. And the platform engineering team worked closely with development teams, offering direct assistance. This approach, known as close collaboration, aligns with concepts from team topologies by Matthew Skelton and Manuel Pais, where tight collaboration is essential in the early stage. And over time, as we better understand the needs and challenges, we start to automate more and more tasks, moving step by step towards a true self service experience. Okay, that's all. Thank you all for your time, and I hope this talk has given you some useful ideas for your own journey with internal developer platforms.